Welcome to yet another Pneuma of Now podcast, where we explore the hidden depths of reality and search for the nuggets of truth that lie within the fabric of the cosmos. I'd like to take a moment and thank all of the new subscribers and to welcome all of you to this ever-growing tribe, united in the pursuit of understanding and wisdom. So as you join us today, this is your host, Richard Blankenship, the triple guru of Kansas, but let's remember, we're not in Kansas anymore. So, as you join us today, let's ponder a couple of questions. What if the universe is not just a random collection of particles, but a structured and interconnected system? How can we restore intuition to physics and uncover a deeper understanding of reality? We invite you to share your thoughts with us and join the conversation, because we're going to dive into these waters, and I always say, dive on in. The water is fine. So in this episode, we are going to introduce you to a concept under a new language, but it's the same concept using a couple of words that other people are using, so that we can add context to what it is we're doing here. We want to introduce you to this idea of ontological mathematics, sort of like an alternative science that offers a holistic approach to understanding the universe. This fascinating field of study aims to restore intuition to physics on all scales, thus providing a fresh perspective on science and reality that challenges conventional scientific paradigms. As we explore these ideas, it is crucial that we create an open-minded community where each member feels free to express their thoughts, opinions, and ideas without fear of judgment. We believe that it is through respectful and constructive conversations that we can truly expand our understanding of the world around us. To help facilitate these discussions, be sure to check out all the links in the description if you're interested in an exploration of what we're talking about, a deeper one, because we are scratching the surface. We're continuing to speak of these things in a way that will allow newcomers into the fold of this new understanding. But really, before I wrap up the introduction, I just want to recap the goal for the podcast. We are on the march to 1,000 subscribers. We might be at the 300 mark here not too long from now. So thank you to every single one of you who have taken the time to listen to the content up to this point. But we really are moving the needle forward. We've got lots of momentum, and we are definitely on the move in 2023. And so one of my goals is to continue to create an open-minded community for the pursuit of truth that provides a safe place for exploration and discovery, okay? This entire channel is an invitation to join us on the journey as we unravel the mysteries of the universe and challenge conventional scientific paradigms. That's what we do. So thank you for being a part of this growing community and for your support. You are seen, and your encouragement, your divine encouragement, does not go unnoticed. We're excited to embark on this journey with you and look forward to hearing your thoughts and insights as we delve into the world of ontological mathematics together. Stay tuned for the upcoming episodes, and don't forget to share your thoughts with us along the way. Okay, so at this point in the conversation, I think it is a time to really point out, I am here to challenge you. Okay? That challenge is very uncomfortable for most people. Okay? So, the new perspectives, plural, are going to challenge the concept of everything you thought you knew. I'm going to repeat this. We're going to challenge everything you thought you knew. And I wish I could make this process simpler for people. And so a lot of the time I spend here in contemplation really is just sitting here figuring out how I can help people to break a cognitive dissonance. You know, trying to fix the standard model, it's no joke. The good news is it's been fixed. The bad news is the world has an aversion to truth. But there are certain individuals out there who, when they see the truth and when they feel the truth, they can kind of know it's true and also know that there's more to it. So as we challenge our convictions, we're going to continually remind ourselves of this philosopher's agreement. And we're going to inspect the content of ideas. And we're going to do that in a way that is very different. And so you got to go along step by step here. I'll make as many references as I feel necessary to make the points ring true. If the points here do not ring true, all I ask, it's a very simple request, is that you just point out the flaw so that we can look at it and correct it, or maybe even upgrade our communication. You know, there's a group of people working together to create a new mode of analysis, okay? Totally different. You can't go into this with your old thought patterns. I'm going to do the best I can to connect it up with the giants, the shoulders of giants on whom which we stand, okay? So we are going to reference the past, but you must be cautious of those references only because those references are going to automatically insinuate a certain language. And that language is what we're trying to upgrade. The current language has failed us, okay? So we are re-enunciating, we are re-articulating a few misconceptions. And those few misconceptions have most definitely led to a multitude of consequences, all of which we can address. Whether or not you enjoy the description and the thought structure that we present to you is not my problem. These are the research studies of many individuals culminating into a unbelievable array, a matrix of unbelievable accuracy that the world is not familiar with. And I like to remind myself there's never a crowd on the leading edge.
Bear with me, Richard.
There we go. I think so.
Hey.
Well, hello. Great to All right, we're going to have to get used to the time delay here, but so good to see you, and thank you so much for short notice. So.
No, you're right. Thanks for working out your schedule too.
Oh yeah, I've got the whole rest of the night off. I mean,
time zones suck.
Now it just takes a quick calibration, you know, that measuring device.
It's always the problem with the US. The UK is not so bad. Normally they're in semi-reasonable times, but US, Australia, always problematic.
All right. Well, are you doing all right? You're doing good?
Yeah, doing fine.
I mean,
not working on the stuff I want to work on, but working.
Right. I mean, are you fielding many Tetryonic questions right now?
They come and go. I had one last night. Wanted to ask them some questions, and it was basically, what do you want people to take away from your books? So I answered it, and that was the end of his discussion. So short and sweet.
Yeah. Well,
Nothing too in-depth or anything like that. Occasionally you get some in-depth ones, and I started delving in, but then the conflict arises with what they're thinking and where they're going, and you got to start from scratch again and go back to the basics and explain why I'm explaining things the way I am.
Kelvin and I are just going to sit here and talk. So welcome to being a fly on the wall. I always wanted to be a fly on the wall for all of Kelvin's discussions. So we're going to let you guys in on some of this stuff. So
no, fair enough.
I think what I'm going to do here is, do you have any just kind of brief updates for the audience on what you're kind of working on or planning or thinking? Or at this point, you're just waiting for students to kind of come more into the fold and ask questions and start applying this knowledge to their actual real world stuff?
I keep answering questions from people that are interested, obviously. I mean, like, some of them are long, some of them are short discussions, some of them repeat, some of them just come and go. That's the nature of the beast with new information, particularly when, as you know, with Tetryonics, we release something so radically different to the way of thinking. We get rid of unit circles, and we show how unit circles are, if you like, a false geometry for the mathematics, and we can reinterpret everything they do with their unit circles and their spheres for spherical point particles as equilateral Planck quanta or Planck coins, and how we can, excuse me, then translate all that in and define mass and matter in a new and exciting way that can be visually understood. And then they can either go one of two ways. They can just take it as I explain it, or as we explain it, and present it and digest it and see what their brains come up with. Sometimes they're on track, sometimes they're off track. Guidance is always one of those things. It's just like university. You can read the textbook, but you may not pull out the gems or the information that it's trying to convey. So a bit of cross-pollination back and forth and re-explanation. I had one the other day where we wanted a quick discussion, 15 minutes tops, on the difference, how to explain mass, energy, matter. And the lady concerned thought she had it all nutted out from previous discussion with me. 2 hours later, the light bulb went on, as you know. I mean, like, it's one thing to think you just picked up a book and you understand the basics, and yeah, I came across it. But when you get into the bells and whistles, the nuts and bolts of Tetryonics and what it is really trying to convey in those slides and the information, and what we can really do with that information as a jumpstart for technologies and scientific understanding, two different things. So some of the discussions are very short and sweet. Like I said, they're getting a feel for it. They're playing around. They're trying to digest in their own mind, waiting for their brain to catch up with this whole paradigm shift that I'm presenting and deciding whether it's real or not. And then there's others that just jump right in. It meshes with what they're thinking or where they're going, and they can see the potential. They can see where it's heading. They've just got to jettison a bit of thinking of their own, just as I did. As you know, electrical engineer, I thought I had it all figured out. I didn't think much of the electrical engineering training other than I'd just apply it and the answers would come out. It wasn't that way. I had to relearn everything I had as a mind model of how electricity works and electrons work and what they look like. But it all came in handy. From there, it's just bubbled along, as you know, over the last, believe it or not, 15 years now. We've progressed from simple models, just like Richard's holding up there with my old favourite. Print out the models on paper, stick them together, then advance them, colour code them, put in their electromagnetic properties for each Planck coin so we can see how each quark's spatial work, how they come together, why they come together, and the patterns they do to make the molecules they do. And in the process, learn. I'm still learning. I mean, like, it was just last week I sat down and I was looking at a sci-fi show, And on one of their shoulders, they had an emblem of a triangle and a rhombic on the side, making an equilateral. I went, oh, that's interesting. I hadn't thought of it that way. And made a whole new spiral, looking at prime numbers and things like that. And it was a pattern, again, so simple, always there, but it never really occurred to my brain to look at triangles spiraling about each other in an equilateral triangle. So there's a whole new outcome again, clockwise, anti-clockwise patterns. I'm playing with that. 15 years later, still playing, still applying, still looking at things. About when I get time, having bought a house and moved in and done all the things you do when you move into a house and start furbishing and earning money in the meantime to pay for these things. I want to get back into the experimenting side of things. I've got my own dedicated little shed now, so I start really launching into it. There'll be batteries and devices and communication gear, things like that. So trying to do baby steps with the practical side from now on. Spent a whole year doing version 3, getting it all up to date with table of contents and things like that, so it's easier for everyone to navigate around the ebooks. Now it's all done. Makes life easy for everyone.
I've been loving version 3, and I just want to kind of point out for myself. Oh, I got 2 things real quick.
You're right.
So I've always kind of taken it as a kind of artistic approach as well. So it is a scientific endeavor, but it's also this artistic approach. Just like what we have here is the Egyptian pie. That's just fascinating how there's an approximation for the Egyptian pie with the enneagram by Gurdjieff, the 4th way, guys. I mean, come on. If you watch this stuff and you pay attention to what Kelvin's presenting, I'm telling you, it's going to blow your mind and you're not going to recover. Like, I always say that, and I say that in a good way. Like, I've been touched by Kelvin's work. I'm actually trying to extend Wayne Roberts' work. And so Wayne Roberts has his own Utragon theorem, right? That's just the pure mathematics. And he has his own paintings. And I wanted to put this painting together, which is a different, it's still following the Utragon formula. But you were talking about how the triangle's spiraling inside of here.
Yeah.
I got a pop quiz for you. I want to see how fast you can figure this out. What's the area of this triangle, assuming that this is 1?
Hey.
So that's kind of the work that I do, weird creative stuff, and I'll show you some of that in a moment. But this is I haven't finished this painting yet. I want these lines perfect. But if you look at this, there's enough information there for you to get every area of every triangle. And there's a nice number in here that I really like.
I'll leave it up to you, because I would actually sit down there and play with that for quite a while.
Well, I mean, I'll let you. Do you want me to give you the answer, or do you want to play around with it? Because it's fun.
Shoot the answer will save time, yeah, but I'm intrigued.
Okay, so I'll just explain it if you want me to. All right, so this is a 4x4. So 4 squared means there's 16 area. So if this is 1, 2, 3, 4, this is also 4. So that's
4.
8. So you know that these are 2 apiece. 2, 4, 6, 8. 8 and 8 is 16.
Yep.
So then down here, you've got 2, 4, 6, 7, 8, 9. So that's a 7. We turn the triangle into a 7.
Really cool.
Yeah, it's beautiful. I mean, this is what gets me excited. And it also shows the power of like, whoa, wait a second. There's something here that people don't quite grasp. If you're immediately dismissing Kelvin's work, you are really missing a lot of layers. And that's fun. And then, what was the other point?
That's the biggest fun in Tetryonics, just seeing the patterns emerge, seeing what they're teaching you and exploring new ground, finding out things. As I said, I was playing around with, probably not going to show up too well there.
Not with the background off. Just tell if you have a picture or a slide or a number. We can.
I can shoot it through to you.
Or just give me a page number, I've got version.
Not in the books. Not in the
Oh,
book.
oh,
This is brand new.
oh! I got you. I got you.
It's brand new spiral pattern. I'll send it to you. You can
Okay.
incorporate it if you like. It's something that's been staring us in the face. It's a rearrangement of the old 13579 into a spiral within the equilateral squared numbers, and it gives you a spiral, and it's just mind blowing when you look at it. You go, that's been sitting there, and even I missed it. So amazing. It just produces clockwise and anti-clockwise rotations of the bosons within the scalar energy. So there's all sorts of ways, and that in itself suggests that there's other ways of constructing energy or EM waveforms that I hadn't thought of. So there's a whole track I can go down there and explore and see what technological use we can put that to.
I mean, I think anything with the spirals, because I mean, everybody thinks that there's a whole class of philosopher who is just stuck on the spiral and of vectors.
It's not even that, Richard. It's more the shape itself. Just the fact that the triangle is square meters per unit of time, square meters per second. There's your what classical or modern physics even would term a spin or a curl or a flux. I tend to, being electrical engineering background, I think of the curl as the electromagnetic curl and the fluxes, etc., in one direction or the other, because as you know, you can also model all the triangles as a inductor wound up that's short-circuited into a triangle. So if you apply energy to that, it will flux one direction or the other. But so far as Planck's constant, squared meters is the physical form, it's the equilateral form. Per unit of time, that's how we measure things. We measure the amount of how much energy, be it mass or matter, that has changed or moved per unit of time to give us that. If nothing moved, nothing changed, we couldn't measure time. You think about it. A snapshot of the universe frozen. There'd be no way to measure time. So all these little triangles interacting, moving, pushing, pulling, etc., give us what we use as a way of measuring time. They give us change in the universe. So it's not even a imbued motion, if you like, in that triangle. It is the triangle itself sitting there. If we were able to zoom in right down to the Planck scale and see that little soap bubble equilateral triangle and see the two sides, it would have this bit of like the film, it'd be swirling one direction or the other. But that's where physics itself, be it quantum or be it classical, get mixed up with their English words. They call it spin, they call it curl. Kyle Hill still thinks of the equilateral triangle rotating as its spin, when in fact it doesn't have to rotate. It can, but the rotation is really a polarization of light. It's got nothing to do with spinning or curling. So when it comes to Planck's constant, the angular momentum, the omega, is just the form per unit of time. However long you measure it for, it determines what that particle or what that field, electromagnetic field, is going to do in that time. How many triangles go past or how many triangles move in that region of space. So all the other terms of spin, curl, flux, etc., do come out, and they do play the classical roles that we've been taught, be it electromagnetics, be it spin of an electron when it's bound to the nucleus, etc. But we're in Planck's constant example itself, the Planck's constant, which is kilograms square meters per second, which is again explained as mass omega, is the physical measure of energy in an equilateral form. That's the building block. So there is no imbued motion. There just is. It sounds a bit religious, if you like. I am. I exist. It is what it is. It's a equilateral quantum of energy that is positive on one side, negative on the other. It can be modeled as an inductor that has a curl of energy creating a north-south in one direction, or an opposite curl on the opposite side of the coin that has a south-north. And that can be defined as a spin as well. But if you take the physical model that you printed, like you showed before, with the electric and the magnetic dipoles on it, the quantized angular momentum is that printed triangle. And it's just us spinning, polarizing it, moving it about, that are different forms of spin and flux and curl. But if you want to model it electromagnetically to create technology, you would probably more correctly refer to the energies, the electromagnetic energies, as, or electrical energy curling to create magnetic dipoles within that triangle. They're not actually doing it, they're inherent in that structure. But that's how we perceive it, because that's, again, it's probably an artifact from my brain, but the best visualization I've come up with is a triangle with a soap film in it. The soap film will naturally spin itself around in one direction on one side, but an observer on the other side will see the opposite spin. And that's technically that's really what we're describing as these 2D Planck coins. They are just a membrane of energy. And that gives us a measurement of mass when we measure the unit energy per unit time. And when they combine tetrahedral forms by putting 4 triangles together through the electromagnetic interactions we call the strong and the weak forces, we can create all the particles. We create tetrahedra, which are tetrons, hence tetrayonic theory. I've toyed around with a lot of names over the years to change it and all the rest, but I still keep coming back. We've got to teach people the difference between mass and matter. Once they grasp the difference between the physical and the ethereal, we can start to do some amazing things. Your brain then starts to understand the role of the physical body and the physical world that we live in versus the entire universe of ethereal energies that are out there, and how we can play around with mass energy versus mass matter and create a lot of wonderful things, along with a much better understanding of what's going on.
Well, is there any work that's come out in the last couple of years, any researchers that you're following, whether you agree with the description of their experiments? Is there anybody you're paying attention to that's kind of really on the right track?
I follow a few. They tend to come up with the right technologies, and they're branching into the ideas, and some of the explanations, even last night or the night before, gets a bit of a blur at times, balancing everything. I was reading one description of Tesla's work just out of a handbook where he'd drawn pictures, a bit along the Walter Russell style of things with vortices. But take away the illustrations, his description of Tesla's work and transmitting power instantly to any side of the globe or any side of the universe, or in his case, he was talking about energy power. You can use it for information transfer as well. Equally apply. His descriptions were spot on. It was just like Tesla, he was missing the triangles. If he can now translate what he visualizes in his head of Tesla's work back into triangles, suddenly he'll have a better grasp of what Tesla was doing. And I've got no doubt if Tesla was standing here beside us, he'd have the same struggle. Everyone has their own mind map of what an electron looks like, and experimenters are devising experiments. And that was Tesla's great failing, was he could experiment and create things, but he didn't necessarily understand where he was going or what he got. He just said, this is the result of doing this, and I can use this to create something, a technology, and it was his Colorado experiments where he switched away from AC and went to DC discharges, high frequency, and discovered that he could do a lot more with that than he could with the AC waveforms that he'd founded. So he was on the track, but without lacking a physical model like we have here at Tetryonics. it's a bit hard. I mean, like, it took years, Steinmetz and all the rest, to explain his work with AC motors and to get it out there in the world in a major fashion, in a replicable, engineered, structured way. Because Tesla just built things, got them working, wrote the patent up for the main key product, and then launched it to make some money. And that's what he did over and over and just kept repeating it until he got to the point where he knew what he could do after Colorado, and he knew what he should be able to do, but A, his theory was lacking, and B, he was in a rush because he was getting in the latter years in his life, and he wanted to make his last big score. In short, people will argue over that, but he wanted to get Woodencliff up and running. He wanted to get, and increasingly towards the end, he started going to the wilder side of what you can do with this technology, and that is communicate across the galaxy and all this sort of stuff. It's all well to talk about it, but if you don't have a solid theory that can explain it all, and you aren't willing to explain it step by step, then you're going to get lumped in just like he was with the crazies, because he's offering faster than light communication and instantaneous energy throughout the world for free, and all the things that people just go, now hang on a second. We've got some well-defined, well-engineered understandings of how things work. Einstein's got relativity. How does that mesh in? Well, I don't know. I don't agree with his work because I'm more of a classical guy, and if Newton says there's a action and reaction, then that should be the same with curved space-time. So they had fundamental disagreements because he couldn't reconcile it the way I did. And I had the same problems. Is gravity push or pull? Is it a curved space-time? It comes down to how you mathematically model what an electromagnetic field is. General relativity was born from special relativity, which was a study of electromagnetic forces in a bar magnet moving through a coil. And what it's describing in curved space-time that continually gets regurgitated, if you can just picture a cloud, a bit like a satellite cloud floating around the Earth, or the atmosphere around the Earth, the electromagnetic field around an object is comprised of all these Planck coins. And if you map it out, you can either map it out through its forces like Newton did and said, well, basically it attracts things gravitationally, or you can map it out like Einstein said in electromagnetic waveform and say, well, the Earth is surrounded by an electromagnetic field. Stars have a bigger electromagnetic field, and that electromagnetic field is just an energy gradient. The sun's got a bigger energy gradient, more energy in that field than the Earth does. So a photon, which is electromagnetic energy, passing through it is going to be deflected, refracted. And that's the bending of starlight. It's not gravitational. We term it gravitational because of our ignorance of what's going on. But the plasma environment of a star will bend light, just like the Earth bends light in all the gravity tests they've done recently, in the last 10 years. I'm showing my age now. And the GPS anomalies that they continually bring up to say it's a confirmation of general relativity. We have to adjust the time on our GPS satellites, otherwise they get out of sync. It's because it's not the photon going down that confirms gravity, it's the photon moving through an electromagnetic density, and it'll slow down. Light moving through any medium will slow down if you change the medium. Change the energy density, it's the same as changing the viscosity. It will slow objects down. It will bend them, refract them. So what we had was mathematics leading the way, but without a model. The mathematics just gives you these results, and they get interpreted in different ways. But through the lens of Tetryonics, you can say, well, okay, if you look at the Earth, or if you look at the sun and the Earth, or the sun and the moon as gravitational objects, what's happening? The physical body is pushing out all the space and the energy of the universe by displacing it by its sheer three-dimensional presence. And the universe wants to push back on these objects because it's like a balloon underwater. Inflate the balloon, the pool and the water in the pool will push back on the object unidirectionally back to the center of the object. Doesn't matter what shape it is, it will know the shape because it's displacing the water. So that's one part of the puzzle of the push and pull. There is a gravitational, very weak component created by matter itself that will always be a convergent push towards the center of the object. But there's also the electromagnetic field around the objects that have push and pull, which goes right back to the illustrations that Richard's flicking through there. The push and pull of Coulomb's work, hence why Coulomb's equation is mathematically identical to Newton's for gravity, but charge interaction and gravity are 10 to the 50 times different. Gravity is a very weak force. Electromagnetic interaction is a very strong force. So the moment your particle, your three-dimensional particle underwater, say, has an electromagnetic field that can draw objects and pull and push them around, that pull and push dominates over just the strict gravity of an object. Hence why we have spherical galaxies that don't have an electromagnetic field, so all their stars will form in a spherical shape. But the moment that the galaxy has an electromagnetic center or can create its own electromagnetic field, it pancakes out into spirals and pancake galaxies because you'll have an electric component as well as a magnetic. The magnetic top and bottom hold the stars in towards the center. The electric forms a chain or a wheel, disc, out to the edge of the stars and keeps them all moving at the same speed as the center, resolving the anomaly that's created by the velocity of stars in the outer rims. It's all explained by these invisible, or hitherto invisible forces of electromagnetism and the difference between mass and, well, two-dimensional mass energy, three-dimensional matter. Once you have the model and you can say, this is a difference, this is a three-dimensional planet pushing ether energies away, that's gravity, very weak, doesn't do much except pull the moon towards the Earth and the sun, the Earth towards the sun. Once you add the electric or the electromagnetic fields, but the electric in particular, the electric component, you have this push-pull that can interact between the planets and their satellites and the sun and their satellites. In doing that, you then have an explanation for why, and this goes back to Bohr's atomic model. When it originally was thought up with an electron floating around a nucleus, they said, well, why doesn't the electron, negatively charged, spiral into the positive nucleus? Why does it only orbit in certain spots? Why doesn't it spiral in and just destroy itself? Because they're attracted. And the answer to that, it doesn't often get applied to planets because they're considered neutral, even though they're not. Everything's made up of positive and negative charges. But their resolution was to make it fuzzy. Sometimes there, sometimes not, sometimes in different orbits, jumping about, not actually there, dumbbell shapes, etc. That was their resolution. That's not what happens. And in the case of planets and stars, what happens is it's the electromagnetic connection between them, i.e. the electric universe, which should be the electromagnetic universe, which allows this push outward. And that push outward achieves one thing that still doesn't get explained in modern cosmology, and that is it creates a stable orbit because the sun is pulling the Earth towards it. The Earth is pulling the moon towards it. They should all spiral in eventually, but we know from measurements of the moon with reflectors that the moon's moving away. We know we're in a more or less stable orbit, even though it's slightly elliptical, but more or less circular. How do you maintain a circular orbit without spiraling in? And the only explanation any physicist, if they're being true, will say is you have to apply a force. You have to accelerate the object to work against the gravitational attraction to keep it in a stable orbit. Otherwise, just like a shuttle in the upper orbit, it will decay as it loses velocity and drop down. The only way to keep the ISS or a shuttle in orbit is to accelerate it into a higher orbit. Otherwise, it will decay and it will collide. So the sun is putting out a vast electromagnetic field. The Earth is attracting the Earth gravitationally in a pull fashion, but it's also pushing and pulling on the Earth's plus and minus charges to create this accelerative force that keeps us stable. The same thing, that same energy heats up the Earth, increases and decreases our electromagnetic field, and does the same thing to the moon. It pushes and pulls on it, but at the moment, in our time frame of measurement, it's pushing it, and it's moving the moon away from us. If gravity is strictly a attractive force, as modeled and explained by Newton and everyone ever since, why is the moon moving away from us? There is no explanation short of a scientist suggesting that there's rockets on the moon that fire periodically to push it away. It's moving away because the sun is charging up the Earth's electromagnetic field and acting against the moon and moving it slightly further out. Should the Earth's electromagnetic field weaken because the sun's output weakens, that distance will drop back over time as the moon loses its velocity from the acceleration, from the lack of acceleration, and the moon will move closer. But while we have an electromagnetic field, it will sit there and it will move away while it's being pushed against. So in short, a bit of a long-winded explanation here, but with my struggles of what is gravity and is it curved space-time, is it just an attractive force? Do we go right back to the earlier models and the early explanations? Because there's many models of gravity trying to explain it. Tetryonics actually ended up saying you've got to account for all these forces. The gravitational force by the presence of matter, which is strictly attractive. You've got to account for the electric and the magnetic forces. The electric force in particular, because it'll push and pull, and the magnetic, because it perturbs, it keeps things balanced, if you like. It gives direction, just like the accelerators. The electric force pushes the beam around, or particles around in the accelerator. The magnetic forces confine it to that raceway. And that's what's happening in our solar system, or in our Earth-Moon relationship. It's happening within the solar system. It's happening within the galaxies. They're all three forces have to be accounted, and they all then give you an understanding of why galaxies are spherical or cartwheel, why they're the shape they are, how they function, and we get back to a more Newtonian view of the universe, because now we can visualize these halos, not of dark matter or dark energy around stars and galaxies, but of electromagnetic fields that surround each galaxy, each star, each planet, and even particles for that matter. Each biological compound has an electromagnetic field that's unique to it. Once we understand that, we realize why Coulomb's equation for charge interaction is identical to Newton's equation for universal gravitation. And now we know we can superimpose both over each other, and that gravity is really a three-way force. It's the pulling of matter versus the electromagnetic interaction of those bodies on each other. So you then have this explanation that no one's ever had. And all Einstein did was, he said, Newton measured the force, or calculated the force. He never measured it. That came along 100 years later. But he calculated what the force should be from the mathematics, making mathematics the way you go if you wanted to try and understand things. And said it's an inverse squared law. Here's the constant, and this will give you the orbits. And it's worked, and it always works. It only fails when you're close in the strong electromagnetic field bodies, because you've changed the density that the body's moving in, changed the interaction of the electric and the magnetic forces that are acting on it. So Einstein had to seek a solution. Einstein did it by saying, I know the pattern or the orbit that Mercury follows. I'll do a calculation of how a particle should move using basically fluid dynamics, curved space-time, and then modeled whatever it is that this body's moving in and calculated in fourfold Riemannian space-time the equation he needed to describe it. Had a race with Hilbert. He won by a matter of, some would argue, hours.
Okay, well, hold that thought.